Alright guys, this is the video for the Unit 5 review, 5.1, 5.4, which is identities, solving equations, and proofs. This is the notes from class. So, reminder, office hours Wednesday, lunch and after school. Your test is Thursday or Friday, depending on your period. You will have no graphing calculator. You will be given the identities, and you'll be given a blank unit circle. So a refresher on the identities is here. You did this in class, but you just want to make sure you're familiar with them and kind of, again, you'll be given them, but just knowing kind of what they are and when to look for them is helpful, not just depending on looking at it during the test. Okay, we're gonna get started. So I would really, guys, the unit circle, we've talked about a lot. We have to have it down. So it's here to practice. If you're not 100% confident on it, make sure you practice that, make sure you're ready, because it's really hard to answer the questions if you don't have a unit circle. Okay. All right, let's start with the multiple choice. So, starting with a relatively straightforward one, which of the following statements is not true? This is just stating some identities and which are true, which are not true. Okay, well, we know sine squared plus cosine squared equals 1. That's true. If we move sine squared to the side, we know that also must be true. And then we have 1 plus cosecant squared equals cotangent, and secant squared minus tan squared equals 1. So one of these is incorrect. Well, we can look at our identities, right, on the first page, and we can see that, well, tan squared plus 1 equals secant squared, and 1 plus cotangent squared equals cosecant squared. So that means that if I rearrange this, I would get tan or secant squared theta equals 1 plus tan squared theta. And since that matches, that one is also true. So this one is not true. 1 plus cosecant squared does not equal cotangent squared. Okay? Which of the following is equal to cosecant theta? We can evaluate these. So this is sine, or simplify these. This is sine times sine over cosine. So this is just sine squared theta over cosine theta. Okay, that doesn't seem to be this yet. This is secant times cotangent. So secant, again, that's 1 over cosine times cosine over sine. The cosines here will cancel, and it'll be 1 over sine theta. So we found our guy. 1 over sine theta, remember, that is cosecant theta, so it must be B. Okay, so you just want to simplify these and see which one matches. Okay, solve the following for all values between 0 and 2 pi. 2 cosine theta squared minus cosine theta. So remember, in general, when you're solving equations, you're usually setting it equal to 0 and factoring. The only time you're not setting it equal to 0 and factoring is if it's just a single trig term. What I mean by that is, if you had, for example, sine squared theta equals 1/2, or cosine theta equals 2, and just as examples. In each of these cases, you're not setting it equal to 0. You're just able to get sine or cosine alone, or the trig function alone, and evaluate it. This is obviously not possible because cosine can't be 2, but I'm just trying to make that comparison. These are cases where you're just solving for sine or cosine. So this would just be sine theta equals plus minus root 1/2. However, in this case, when you have multiple terms, multiple trig terms, or a mixture of trig terms, you're going to be factoring and setting it equal to 0. So this is already set equal to 0 for us, and then we're going to take out the greatest common factor if possible. So in this case, yes, we can take out a cosine. So cosine comes out, cosine theta, 2 cosine theta minus 1 equals 0. Then we're going to set each of these individually equal to 0. So cosine theta equals 0. And cosine theta equals 1/2. And then we say, okay, well, where on the unit circle does this happen? So again, during your test, guys, everything will be on the unit circle. There won't be any kind of inverse trig on the calculator. It'll all be in the unit circle. So we ask ourselves, okay, well, when is cosine 0? That's at pi over 2 and 3 pi over 2. Okay, so it's between these two right now. Where is cosine 1/2? That's at pi over 3 and 5 pi over 3. So it's got to be this answer here. I know it doesn't have a letter, but that's our answer. Okay, does that make sense? What angle is this true? And if you were like really stuck, again, we could go here. We could look at the unit circle. I know it's not filled out. Let me grab what is filled out. Okay, so just an example. You won't have this, but just to make it sure I'm being clear, when is cosine 0? That's at pi over 2 up here, and at 3 pi over 2 down here. When is cosine 1/2? That's at 5 pi over 3 right here, and pi over 3 right here. Okay, so that's where those answers are coming from. Those are the angles that make that true. Okay, next up, which expression is equivalent to cosine x minus pi over 2? Now, you may remember this as a co-function identity. However, let's just say you didn't know that, or you couldn't understand that from the identities that were given to you. You could use a sum difference to evaluate this to see what it equals. Let's practice that. So if we use sum difference, it's going to be cosine x cosine pi over 2 plus sine x sine pi over 2. This is the cosine difference identity. Cosine pi over 2, well, we know that's 0. So this is 0 right here. So therefore, this whole left side must be 0 because cosine pi over 2 is 0. 0 times anything is 0. This is all 0. Over here on the right, sine pi over 2 is 1. So 1 times sine x, that's just sine x. Therefore, this must be just sine x. So if I give you a problem with any kind of addition or subtraction inside the function like this, that's kind of a hint to you that you're going to use those sum or difference identities and to just plug it in and see what it equals. Which of the following is equal to 2 cosine theta? So this is similar to the previous one where you're going to simplify these and see which one will get us here. So the nice thing here is it gave us sine 2 theta, and there's only one choice for sine 2 theta, and that's 2 sine theta cosine theta. That's your double angle identity that will be given to you. I'm going to just simplify these. So for A, 2 sine theta cosine theta times cosecant theta, which is 1 over sine theta, right? Then these will cancel. So I'll just have 2 cosine theta. Okay, so we got lucky. The first one happened to be right. When I converted it to 2 sine theta cosine theta, and I multiplied it by 1 over sine theta, which is cosecant theta, I just got 2 cosine theta, so it must be A. But for these, you would convert to 2 sine theta cosine theta and simplify and see which one got you to this point. Okay? All right, short answer. Determine the exact value of the following. Okay, so you may get this in degrees. This is degrees, right? Or you could be given it as like a radian. Okay, so if you've got it in radians, you can do it. You can add up the angles in terms of radians, or you can just convert this to degrees. So you could say that, okay, that's really just cosine 15, and then you could do it from there. But just be ready to do either of these. Okay, either of these. So 525. If you're given an angle that's outside of the unit circle is from 0 to 360. So if you're given an angle that's beyond 360 or below 0, let's just get it inside the unit circle first. So first thing we're going to do is do 525, and we're going to find the coterminal angle inside the unit circle. So we're going to subtract 360. When we subtract 360, we're going to get, let's plug it in, 165. Our next goal, again, you will be able to fill out a unit circle, but our next goal is 165 is over here. How can we make 165 with the angles that we're given? So I can see, okay, well, 120 plus 45, that's 165, so that's going to be my sum. So you're going to do sine 120 plus 45. Then we're going to do our sum difference identity. So sine 120 cosine 45 plus cosine 120 sine 45. Sine 120 is 3 over 2. Cosine 45 is 2 over 2. Plus cosine 120 is negative 1/2. Times sine 45 is root 2 over 2. Okay, this will become root 6 minus root 2 over 4. Okay? And if you have like an alternative way of writing this simplified, that's okay. But this is our final answer. Okay? All right, last one here. So we've got another sum identity here. So if cosine x is 3 over 7 and sine y is 6 over 7 with both x and y quadrant 1, then find sine x minus y. You may leave unsimplified. Okay, so what is this going to be? This is another sum difference identity. We're going to apply the difference identity, so it'll be sine x cosine y minus cosine x sine y. Now we already know that sine y is 6 over 7 and cosine x is 3 over 7, so these two are good. I know what these values are, but I don't know what sine x is, and I don't know what cosine y is. What we have to do is off to the side, find those values. Okay, so I'm going to draw a triangle. Let's call this x, and I know that cosine of x is 3 over 7. So I just need to use Pythagorean theorem to solve this triangle to find this side here so that I can find what sine of x is. You need to find like the opposite side, okay? So that would be a squared plus b squared equals c squared, so therefore 49 minus 9 equals the opposite squared, so it's root 40 equals opposite, which is 2 root 10. Therefore, sine of x equals 2 root 10 over 7. Okay? I gotta do the same thing for y though. So y, it told me that sine of y was 6 over 7. But we have to find the cosine, we have to find this adjacent side here. So again, we're gonna do Pythagorean theorem. So it would be 49 minus 36 equals a squared. 49 minus 36 is 13, so root 13 equals a. So therefore sine y, or sorry, cosine y rather, would be root 13 over 7. Sorry, make sure that's clear. Okay, so for this one, you have to do little triangles to find what sine of x is and cosine y is. You have to solve the triangle to do that, and then we're able to plug it all in. Okay, so over here, sine x is 2 root 10 over 7 times cosine y, root 13 over 7 minus cosine x, 3 over 7 times sine y, 6 over 7. Okay. It says you may leave unsimplified. So if it says that, you could technically leave it like this. I'm going to go ahead and just finish it. It's going to be 2 root 130 over 49 minus 18 over 49. So that's 2 root 130 minus 18 over all over 49. I'm sure that 130 is not a fully reduced. Maybe it is. It might be fully reduced, but regardless, this is fine. Okay, if you've fully reduced 130 as a radical even further, that's great, but I would accept this just fine. Okay. All right. We got proofs and we got equations. Proofs. Everybody's favorite. So based on the quiz, like this is really, this is kind of what we struggled with the most. Let's do some practice. So again, the goal of the proof is to get one side to look like the other. That's our goal. There are various strategies that we use to do that. Oftentimes, it involves a Pythagorean identity or converting to sine and cosine. So you can do what you like. So I encourage you before watching the video to really try this. Like maybe get a separate sheet of paper, like try and work it out, see what you can do before I do it. Okay. But I'm going to get started with it now. Okay. So for this one, one thing I'm noticing is that this is in terms of secant and this is in terms of sine and cosine. So I want to correct that. So the way I'm going to correct that is I'm going to write the left side all in terms of cosine. So I'm going to rewrite the left side as 1 plus 1 over cosine x over 1 over cosine x. I want to simplify this fraction, but I'm not allowed to keep, change, flip this as it stands. It has to be all together in the numerator before you can do that. So I am going to combine the numerator here. When I combine the numerator, I'll get cosine x plus 1 over cosine x all over 1 over cosine x. Okay, how did I do that? I multiplied the 1 by cosine x over cosine x so that I combined it to be one fraction. Now I can keep, change, flip. When I keep, change, flip, multiply by the reciprocal, I'm just going to get cosine x plus 1, right? Because what's going to happen is this cosine x will cancel with this cosine x. You know, it'll look like this. It'll look like cosine x over 1, and you'll cancel like that. So you'll just have cosine x plus 1. So this left side I have determined is just cosine x plus 1. Okay, so I've done part of the left side. I'm now going to go to the right side and see what I can do with this one to make it cosine x plus 1. I'm totally allowed to do that, okay? So we're going to take the right side now. And I noticed, like, you got the sine squared, you got the 1 minus cosine x. That's a hint to use Pythagorean, right? We're going to multiply the top and bottom of the right side by 1 plus cosine x. When I multiply the top and bottom by 1 plus cosine x, I'll get sine squared x 1 plus cosine x all over 1 minus cosine squared x. 1 minus cosine squared x is just sine squared x. So we'll have sine squared x 1 plus cosine x all over sine squared x. These will cancel, and I'll just have 1 plus cosine x. So now the right matches the left, and I'm done. Okay? So again, I mean, the problems are difficult, and it's not always like a one-size-fits-all kind of solution. You just have to take your time and try something. Try something, and if you're trying something and you're using the correct simplification, you'll make some progress. Okay? Let's try the next one. So one thing that should be stand out to you here is the sum identity here. Like when you see the sum, you got it. Like that's a hint. Use the sum identity. Let's do it. So it's going to be cosine x cosine y minus sine x sine y all over cosine x sine y. Okay, I can rewrite this as two separate fractions. Cosine x cosine y over cosine x sine y minus sine x sine y over cosine x sine y. In each of these fractions, cosine cancels, sine cancels, so I just have cosine over sine y, which is cotangent y, and then sine x over cosine x, which is tan x. This one's not too bad. When you see that sum or difference identity, use the sum or difference identity. That's my hint, guys. When you see the sum or difference, use the sum or difference. Same thing here. When you see a 2x on the inside, use the double angle identity. Use the double angle identity, okay? So again, sine 2x only has one option. It has to be 2 sine x cosine x over sine x. And then on the right side here, we have options for cosine 2x. Since I'm not too sure which one is going to help me the best, I'm just going to choose cosine squared minus sine squared. Okay, let's now combine things together. So I'm going to multiply the left side by sine x over cosine x over cosine x, and the right side by sine x over sine x. So we will get 2 sine x cosine squared x minus cosine squared x sine x minus sine cubed x, or plus sine cubed x. Okay, and this is all over sine x cosine x. Okay, so again, what I did here is I just multiplied this side by cosine x over cosine x. That got me 2 sine cosine squared x. I multiplied the right side by sine x over sine x. That got me cosine squared sine x, and then sine cubed x. That became a plus because we're doing this double negative here. I'm distributing that minus as well. Okay, but the minus goes to this, then this becomes a plus. These two are the same term. So this is just going to combine into a single one. This is what we have now. I'm going to write it over here. We have a single sine x cosine squared x plus sine cubed x over sine x cosine x. Okay, let's take a look at the top. Something we want to look for is like sine squared plus cosine. Like somehow this has to become secant, and there's so much here, it's probably like confusing. Well, how does this become secant x? Like we have so much left right now. But something like one of the tricks that you'll see is whenever you see a sine squared plus cosine squared, that's just 1. So you see like a sine squared plus cosine squared, like you can take out. That's like a really good idea because you can just make that big expression become 1, and I actually see that here. So what I'm going to do is kind of factor out the sine x to the numerator, sine x. I'm going to rewrite it as cosine squared x plus sine squared x over sine x cosine x. You follow me there? How I did that? Well, now cosine squared plus sine x, cosine squared plus sine squared is just 1. The signs will cancel, right? These will cancel. This is just 1. So it's just 1 over cosine x, so it's secant x. Okay? Again, my advice for these guys is the answer is there. This is the answer, right? You're just proving that it can be done. It can be done. So please practice these in 6.4, 6.3, 6.2. It's all on the Google Drive. Like, do those problems. Look at the proofs. Look, you kind of, they're not available on Delta, right? They're not possible. That's my advice. Look at the classwork I gave you. Look at the resources online to practice these more. Make sure you're familiar with the different types. With Delta 6.2, the paper one, right? The key, look at the key for 6.2. Look at them. I put them in the email. They're all online, okay? All right, we're on our last section here, which is equations. So I think, you guys are pretty good on this from the quiz. I saw a lot of good stuff. I'm just going to make sure we're good. We'll run through the different types. First one, different trig equations, but we factor. Okay, so you take out a tan x here, tan x, and then cosine x plus 4 equals 0. And then we set each of these equal to 0. So basically, when does tan x equal 0, and when does cosine x equal -4? Well, this is impossible, so we don't care about that. When does tan x equal 0? That is going to happen at between 0. This is including 2 pi. So between 0 and 2 pi, that's going to happen at 0. So x would have to be 0. Or pi or 2 pi. That's when tan is 0. So again, tan is sine x over cosine x. So what I'm listing here is basically when does sine x equal 0? That's these values. All right. Another problem here, this one is a double angle identity. So see, we got the double in there. That's an indication we got to convert. So we're going to change this to 3 times 2 sine x cosine x. And then I'm going to move this over, minus 2 cosine theta. Sorry, I should be writing in theta. Minus 2 tan cosine theta. And so it'll be 2 times sine x cosine x times, minus 3 cosine. I'm going to change it to x. Sorry about that. But technically it's theta. It's okay. then I'm just going to multiply this through. Well, I'm going to multiply it through for now just to make it a little cleaner looking. Sine x cosine x minus 3 cosine x equals 0. Same thing as above. You're going to take out your factor. So I can take out a 3 cosine x out of the whole thing. So I'm going to do that. 3 cosine x. And then 2, it'll be 2 sine x minus 1 equals 0. So therefore, I'm looking where cosine x equals 0 and where sine x equals 1/2 between 0 and 2 pi. When does that happen? Well, that would be pi over 2, 3 pi over 2 for cosine x equals 0, and then for sine x equals 1/2, that would be pi over 3 and 5 pi over 3. Pi over 6. Sorry, my bad. Not pi over 3. It's going to be pi over 6 and 5 pi over 6. Again, just to confirm that, sine pi over 6, 1/2. 5 pi over 6, 1/2. Okay, last one. This one, we have a mixture of sine and cosine. First thing first, we're just going to move everything over to the left side, make everything make everything on one side. So it's going to be -4 sine squared theta, and then we're going to add the cosine, so that'll be 0, and then we'll add so we're adding 4 cosine theta, adding 4 cosine theta, and then plus the 5, plus the 5. So it'll just be plus 3 equals 0. So actually for this one, so this is kind of like what I talked about a little bit ago. We don't need to convert this or anything because we just have one trig term. Had we not done that, like let's say this was still a cosine here, we would need to use the Pythagorean identity to convert the sine squared into cosine squared so that they were all cosine squared. I might show you an example of that just so you're clear. But in this case, because it's just one single sine squared, we can just get it alone. So we're gonna move that 3 back over. We're going to get sine squared theta equals -3 over -4. So sine squared theta equals 3/4. So sine theta equals √3 over 2, plus minus. When does that happen? That would be at pi over 3 and 2 pi over 3. And 4 pi over 3 and 5 pi over 3. So let me show you an example of what I was talking about if it was, like if we had to convert it. I want to make sure you're good on that. So let's say we have the same problem. I'm just going to make up a new problem. And let's just say that everything was the same. But instead of a -4 cosine theta there, it was a -5. Okay, and so then when we moved everything over, what we would have is -4 sine squared theta plus cosine theta plus 3. Okay, equals 0. If this is what you ended up with like a sine squared and a cosine, that's when you use Pythagorean identity. So you know that sine squared theta plus cosine squared theta equals 1. So therefore, sine squared theta equals 1 minus cosine squared theta. You will then sub that in for sine squared to make everything in terms of cosine. Okay, now this is not factorable, and we're not going to solve this, but I just wanted to show you how that worked. But in general, when you would get to here, you would then, you kind of do that u substitution where you say cosine theta equals u, and then you write it as 4u squared plus u minus 1, and you solve it like a quadratic. So you can do a quadratic formula, or you can factor this, and then you sub the cosine back in to evaluate it. This is not factorable, so you're not going to get, it's not going to be clean, but that is what you would do. Okay? All right. That is on delta. So if you want a practice problem of that, go to the delta 5.2. You'll see these kinds of problems there, equations with substitution from Pythagorean identity. Okay, I hope that was clear. Know the study guide, look at the delta, look at those homeworks and classworks for review of the proofs. Email me if you have questions. Come to office hours today, that's Wednesday. And if not, yeah, just let me know. All right, good luck, guys. See you.